This is haploid and diploid numbers. Number 6. I'm not going to go over numbers 1 through 5. They were fairly straightforward. And a lot of people got them right. If you didn't get numbers 1 through 5 right, then talk to one of the other students, talk to me. When I have a spare moment, I'll be more than happy to help you out with any of 1 through 5. But I think if you see the corrections, and especially if you see my explanation number 6, then hopefully that will help clarify at least 1 through 4. So number 6 says, what can you conclude about the complexity of an organism and the number of chromosomes it has? Hint, are there any single-celled organisms in the table? So let's take that hint first. And let's look at these organisms. We've got an amoeba, a chimpanzee, an earthworm, a fern, a hamster, a human, and an onion. In general, anything that you can see has more than one cell. In fact, it probably has billions, if not trillions, of cells. Humans, we have over 37 trillion cells by most estimates. That's a lot of cells. So all these other organisms, we can see them. All right? And so because we can see them, we know they have lots and lots of cells. An amoeba is a single-celled organism. It is microscopic. We can only see it in the microscope. So that immediately tells us that we should be looking at that in comparison with everything else. An amoeba has a haploid number of 25. And let's just make sure we have all haploid numbers here. So I'm going to put in all the haploid numbers real quick. So in case you didn't get this, the fern has a haploid number of 505, which is half of 1010. Human has a haploid number of 23. Onion has a haploid number of 8. And remember, all those haploid numbers, those are the numbers of chromosomes in each of the gametes, the sperm cells and egg cells. So, going back to this, we're looking at the amoeba compared with everything else, compared with all of the other organisms here. And we see that the amoeba has 25, chimpanzee has 24, human has 23, hamster is 22. Okay, so the hamster, human, and chimpanzee are all mammals. And so roughly the same amount of complexity, but the amoeba is this single-celled organism that isn't even close to being a mammal. So immediately we see there doesn't seem to be a correlation. Well, maybe the amoeba has one more chromosome in its gametes, in its sperm and egg cells. Maybe there's some correlation here. Let's keep looking. Let's look at the fern. Well, the fern is a plant. And the fern has 505 chromosomes in its sperm and egg cells. Well, that's crazy. It definitely is not more complex than a hamster or a human or a chimpanzee. A fern is just a plant. It's got some leaves on it. That seems to be about it. Now, the biologist in me says that a fern is complicated, but at the same time, it doesn't have the amount of organs. It doesn't have the complexity of like having eyes and legs and mouth and ears and all these other things. So it doesn't seem to be that, the more simple you are, the more chromosomes you have, because look at the amoeba. The amoeba is way simpler. And the fern has way more chromosomes in it. So there doesn't seem to be any pattern here. The onion is a plant, of course, and then it has way fewer chromosomes than anything else here. So this is kind of a trick question. There is no pattern. The conclusion about complexity of an organism and the number of chromosomes it has is that there's no correspondence. There's no pattern. You can't tell by looking at the number of chromosomes that an organism has how complex it is. That's the bottom line.